Welcome back. We're going to continue our discussion on organic reactions. Previously, we learned how to go from alkenes to alkanes, and if you see, the same reagent was there. And what would you call this? It's a reduction, because when your reagent is hydrogen rich, it's reduction. So basically, you're adding a bunch of hydrogen to get rid of the double bond. So when it's alkene, you added a pair of hydrogens to get rid of the double bond. When it's an alkyne, you add 2 pairs of hydrogens. So basically what we're doing here is, this is the carbon containing the triple bond, right? If you want to go from an alkyne all the way to alkane, you use this. I don't want to go from an alkyne to an alkane, but I just want to stop at an alkene. Well, wait a few more minutes. Got another video for you on that, or another reaction for you. So basically, you're going to add 2 sets of hydrogen. Okay, 1 gets added, right? And then I'm going to put the other in a triangle, so you know that we're adding 2 pairs of hydrogen, right? So essentially, we're going to add 1, 2, 1, 2. Let's not worry about stereochemistry. You've just added 2 pairs. Every time you add a pair, you get rid of a double bond. In the case of an alkene, you only have to get rid of 1 double bond. But in the case of an alkyne, we have to get rid of 2 double bonds. So our product would just be, if you write it without the hydrogen, that'll be 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So it's just heptane. N-heptane or 1-heptane, whatever. So this is alkyne to alkane. Again, this is a reduction because our reagent is hydrogen rich. But what if I don't want to go all the way to alkanes and I want to control the reaction to be stopped only at the alkenes? This is also reduction, but when you see Lindlar's catalyst, you do not go all the way. You stop, you go from a triple bond to a double bond, and you stop there. In other words, you're only adding 1 pair of hydrogen. So if this is your reagent, right, you have a triple bond, meaning that when you add a Lindlar's catalyst, you're only adding 1 pair of hydrogen. So let's leave one of the double bonds on and just add 1 pair to get rid of just one of the double bonds. So your product would be essentially, you write it without it. I want you to name the compound. So if you don't want to go all the way from an alkyne to an alkane, you use Lindlar's catalyst, which only takes you from a triple to a double bond. Whereas if you want to go from an alkyne all the way to an alkane, then you use hydrogen, palladium, and carbon. All right. So those are the 2 types of reductions I want to show you with respect to alkynes. All right. So stay tuned.